We'll start ALU programming. On desktop, you have to click on cadence_db. Inside that, you have to click on digital. And here already I have created the folder by my name. You people will create by using your USN inside this, and I have already written the program and kept it ready. We'll go for ALU Verilog program and its test bench program. I have kept it ready. We'll get back to digital. While in digital folder, anywhere on the screen, right click on open terminal. Here in this, first you have to invoke cadence tool. For that, csh enter. Then next command is source /test. Enter. Now this is how we will invoke cadence tool. Now we will try to execute the programs. Now you have to invoke or launch simulator. For that, command is nc launch. Enter. Okay, I have already written the programs and all are stored in the directory Chetana. Here, this is the Verilog code and its test bench. Okay, before going to this, we'll see what exactly is the program. I'll directly open it here. This is the Verilog code for ALU module. This is the name of the module, and inside the common brackets you have to write the inputs and outputs. Here the input is there are 3 inputs: 32-bit P and Q, 3-bit select input is there. Next output, which is also declared as register accumulator, which is a 64-bit variable. Okay, these are the inputs and outputs. Then close the bracket. Then behavioral way of writing programs is used here. So always at either select P or Q. This is the sensitivity list. If any one of these 3 changes, the program has to be executed. So the accumulator variable has to be changed according to the changes made to the select variable, P variable or Q variable. Here initially accumulator is given as 0. Now depending on the value of the select pin, corresponding operation will be performed. If select variable is 0, the 2 inputs are added, so addition is performed. When select variable is 1, subtraction is performed. When select variable is 2, multiplication is performed. When select variable is 3, division is performed. Select is 4, logical AND. Select variable is 5, logical OR. Select variable is 6, logical XOR. When it is 7, NOT gate. Inversion has to be performed. Then end this begin. So this always block will be ended here. Then this is the end of the module. This is the Verilog program, which has to be stored with .v extension. Okay, now you can close this. This was the code. Next is test bench program. Here again module. This is name of the test bench program. All the inputs have to be declared as registers and all the outputs has to be declared as wires. So P and Q, 2 32-bit inputs, select 3-bit input, which is declared as register, and outputs. Okay, now this is instantiation of the program to which we are writing the test bench code. This is the module name of the Verilog code. This is the instance name and it can be anything. And this is how we will invoke its inputs and outputs. It has to be exactly in the same order written in the code. So P, Q, select and output. So now initial here, in the Verilog code we had used always. In the test bench code we cannot use always, we have to use initial. So now if select is 0, P, so initially select is declared as 0 at time t is equal to 0. So P is equal to 14 and Q is equal to 18. So these are the values of P and Q. For these values, after every 20 nanoseconds, we'll keep on changing the values of select. So initially at time t is equal to 0, depending on the value of select, the corresponding operation will be performed. After 20 nanoseconds, select value will be 1 and accordingly the corresponding operation has to be performed. This is similarly after every 20 nanosecond the other operations will be performed. This is end of the initial block and this is the end of the module. Okay, now you can close this. Now we will see the execution simulation part. First you have to select the folder or directory where you have stored. So this is where it is stored, in this folder. So now first click on this, and before that you have a look at the tools over here. So none of the tools are activated or highlighted. So only when you select the code that you have to compile, the corresponding tool will be highlighted. So when this is selected, this will be highlighted. The first thing is Verilog Compiler. Click on that. It will be compiled. If there are any errors, it will be displayed here. Then click on the test bench program, compile it. So no errors. Then you can come to worklib library here on the right side. Here this is the code ALUF and ALU test bench. This is the module name here. Now you click on the module name. Then the next tool will be highlighted, which is elaboration. Click on that. Again, if there are any errors, it will be displayed here. Next, consider test bench. Elaborate the test bench program also. No errors. Now you can proceed to snapshots. Snapshot, this is the ALU program and the test bench. Now you select the test bench program and click on simulator. Here we will minimize this console window, and here is a program, module name of the program. Click on this. You can see all the inputs and corresponding values given. Select this, right click, send to waveform window. Now you can see here waveform window is opened. Okay, this is where all the inputs and outputs are displayed. This is the values and this is where the outputs can be observed. Here you click on this. Okay, press this to show the time field. So we have given around 8 to 920 nanoseconds. So approximately we'll give around 400 nanoseconds. Okay, then we will click on run. Since test bench is written, you need not give the values here. So we'll directly click on run. Okay, so these are the values of P and Q and the corresponding outputs. These are the values of select. So whenever it is 0, 1, 2, 3, 4, 5, 6, accordingly, outputs are going to be displayed. This is how outputs can be observed. Thank you.